Hello, 5th grade. This is Chapter 8, Lesson 1, page 551. Lesson 1, Fractions and Division. Essential question, how are factors and multiples helpful in solving problems? Factors are the numbers you multiply. Multiples are like the answers to your multiplication problems. A fraction is a number that names equal parts of a whole, or parts of a set. That's what a fraction is. A fraction represents division of the numerator by the denominator. The numerator is the top number divided by the denominator, the bottom number. If you wrote it horizontally, it would be 1 divided by 3. That's what that means. The numerator is the number of parts represented in whatever you're looking at. So you'd have one piece. The denominator represents the number of parts in the whole thing, the whole, out of 3. So one piece out of 3 that it takes to make the whole thing. 1 divided by 3 is also what that means. Example 1. Fast break for food. Dylan, Drake, and Jade are sharing 2 small pizzas equally after their lacrosse game. How much does each person get? So here's their lacrosse stick. Let's see how much pizza they get. 2 pizzas are divided among 3 people. Here's the drawings. Pizza, pizza. That's 2 pizzas divided by 3 people. Each person gets 2/3 of, it says a pizza, it should be actually the pizza, the entire thing. So each person gets 2/3 of the pizzas. We could even put an S at the end. So 2/3 out of the whole thing. Because it's 2 pizzas divided up by 3 people. So 2 pizzas divided by 3 people, 3 pieces. 2 divided by 3. So 2 divided by 3 is written 2 over 3. The numerator is 2, the denominator is 3. The amount of pizza each person gets is between what 2 whole numbers? Well, I've worked this out, but I want to go back and analyze this, so I'm not going to show that just yet. They had their first pizza, and they divided it equally among Dylan, Drake, and Jade. And then they came over here and did the same thing, equally. Dylan, Drake, and Jade. You can see they get basically 2 pieces. You could call them slices if you want, out of the 2 pizzas. And it's 2 whole pizzas divided by 3 people. The amount of pizza they get is 2/3 of the pizza. Well, 2/3 of the whole thing. So what they want you to think about is 2/3 is less than 1 whole, because in order to make the whole thing, you would need 3 out of 3 pieces, and that would be 1 whole. So in other words, 2/3, the fraction, is between 0 and 1. Because you don't quite have a whole thing. You have 2 pieces out of 3, in other words, is what that usually means. So it was between 0 and 1. Okay, let's see. Let's see if the next one makes more sense or more easily understood. Here we go. Ray and Bailey are sharing 3 brownies equally. How much does each person get? I had gone through this once already. 3 brownies are divided between 2 people. So you have 3 brownies divided by 2 friends, Ray and Bailey. Each person gets 3 brownies divided by 2 people. So 3 halves of, not a brownie, but 3 brownies of, we're going to say the brownies for this to make sense. So they drew 3 brownies over here. 1 brownie in the shape of a square, 2 brownies, 3 brownies. 1, 2, 3 brownies. The models at the right show that each person gets one whole brownie. If you can see, they put their name on it. So Ray got one whole brownie, Bailey got a whole brownie, and the one in the middle they divided in half. So Bailey got half, Ray got half. There is one brownie remaining, that was the one in the middle, which can be divided equally between two people, so they did that. Each person gets 1.5 brownies, one whole one and half of the center one. So, in other words, 3 divided by 2 is equal to one whole, like one whole brownie, and half of another. The reason that is true, as my book is moving a little, is because if you broke them all in half, it would look maybe a little easier to see. And you'd say, okay, I divided all of them into pieces, and, you know, Ray gets one, Bailey gets one, Ray gets one, Bailey gets one, Ray gets one, Bailey gets one. In other words, each person, when you put those halves together, they got 3 halves. 1, 2, 3 halves out of the total. And 3 half pieces add up to 1.5. Because these two went together to make one whole and then half of another. The amount of brownies each person gets is between what 2 whole numbers? They want to know what it is between in terms of whole numbers. And I was saying it's between 1 and 2, because if you were to put it on like a number line or a ruler, 1.5 is between 1 whole and 2. 1.5 lies right in the center. You'd have 1 and an extra half. It's right in the middle between 1 and 2. So the amount of brownies each person gets and is allowed to have is between what 2 whole numbers? It's between 1 and 2. Moving on, let's try one on the next page. So the directions are important to read. And once again, I took a look at this and I had to stop, I was busy. But the directions are, represent each situation using a model and then solve it. 4 families equally share 5 pies. So that's 4 families sharing 5 pies. They've got more pies than they have people or families. How much pie will each family receive? We're going to work that out. Each family receives this fraction, or it's going to become a mixed number, a whole number with a fraction of not a pie, the pies. There's 5 of them. So we'll find out by doing the work. Here we go. And move that out. Okay, here we go. I pre-drew my pies. Okay, there's 1 family. So family 1, family 2, family 3, family 4. And these are meant to be the pies already divided. So I've got 1, 2, 3, 4, 5 pies. And I broke each pie into 4 pieces because there's 4 families sharing them. So family 1 would get a piece, family 2, family 3, family 4 of each pie, just so you can see it. Family 1, family 2, family 3, family 4, family 1, family 2, family 3, family 4, family 1, family 2, family 3, family 4, family 1, family 2, family 3, family 4. There's 2 ways to look at this, but we'll start with this way. Okay, so each piece is worth 1/4 of the pie. So if you broke it into 4 pieces, that's 1/4, that's a 1/4, that's a 1/4, that's 1/4. So you have 1/4, 2/4, 3/4, 4/4 to make an entire pie. So let's talk about sharing. If we gave them each a whole pie, we could go, 1 pie for you, 1 pie for you, family 2, a pie for family 3, a pie for family 4. They get the entire pie. And then you'd have 1 leftover pie that could be divided among the families. And like I said on this one, each piece is 1/4 of the pie. And we have exactly 4 families, so guess what? That works out pretty nice and easily. That would be a piece for family 1. I could probably draw that right there. I was going to show another way, but a little piece for family 1. I'm going to do the slice. A piece for family 2. Another little slice. A piece for family 3. And a piece for family 4. They each get a 1/4 of that particular pie. But they had also gotten a full pie, so I'll draw a circle to represent the entire pie. This is something else I was going to show. A full circle for this pie. Sorry, it's getting sloppy. A full circle for this pie. And these are all meant to be equal, like equally drawn. So each family received 1 full pie and a 1/4 of each of that last pie. Another way to say it, and I had broken all these into pieces, another way to say it was you could have divided them, well, okay, so they each got 1 whole and 1/4. I'm getting ahead of myself. 1 whole pie and a 1/4 of that last pie. If they were all divided into groups of 4, like 4 pieces, the other way to look at it, I was originally thinking, is you could say 1 piece of this pie for this family, a piece of this pie, that's 2, a piece of that pie, that's 3, a piece of that pie, that's 4, and a piece of that last pie, that would be 5. These 4 pieces together make a solid pie. 1, 2, 3, 4/4 is equal to an entire pie, and this was the last 1/4 that was left over. So that could be considered 5/4, which is what the book has been referencing. You have 5 pieces, and they're all sliced into 4ths, 5/4 pieces, which looks like this: 1, 2, 3, 4. If you know, this is a pie that's sliced into 4. And they got put back together into 1 solid pie and a 1/4 of another, 1/4. That is the same thing as 5/4. So that's what the book is trying to teach you today. And so once again, these guys got 1 and a 1/4, 1 whole pie and a 1/4 of another, 1 whole pie and a 1/4 of another, 1 whole pie and a 1/4 of another. And if we label it pies, 1 and a 1/4 pies that they get to take home. So 5 pies divided by 4 people equals 1 whole pie and a 1/4 for each. But you could also think of it, if you divided them into each pie into 4ths, they get 5/4, which is the same thing as 1 and a 1/4. In the book, we would write, each family receives, try and line this up again, each family receives 5/4 pieces, 4ths, or 1 whole pie and a 1/4, you know, that was separated from the group because it doesn't make a whole pie. We had enough to make a whole pie, 1 whole, and an extra 1/4 left over. So 5 divided by 4 equals 5/4. The answer is between, that doesn't make sense, the whole number is blank and blank. I don't think that makes sense, so I'm not going to keep that there because it equals that. Or 5/4. Strange. Okay, it equals 5/4, but whatever. That doesn't help me answer this that well. This helps me to answer this. It's between 1 whole, and if you had more, you could have 2 pies. It's between 1 whole pie, and if you had 3 more pieces, you could have another whole pie. So it's between 1 and 2. On a number line, here's 1. 1 and 1/4 might be right about here. 1 and 1/4 of a pie. 2 is over here. So it's between 1 whole and 2. You've got 1 and a 1/4 pies. You're farther away from being another whole pie than you are to being just one pie. Okay, little abstract. So we'll go on to this one. 6 bags of soil are used to fill 5 flower pots. So we have 6 bags of soil, 5 flower pots. How much soil does each flower pot use? Between what 2 whole numbers does the answer lie? So you've got 6 bags and 5 flower pots. There's more bags of soil than there are pots. A quick drawing would be, well, a pot. 1, 2, 3, ooh, this could be small, 4, 5. 5 flower pots. And then we have 6 bags of soil. And I'm debating if I should switch this. This could be my bags of soil. 1, 2, 3, 4, 5, 6 bags of soil. 5 flower pots. 1, 2, 3, 4. They're meant to be the same size. 5. Each flower pot uses 6/5 or blank of a bag of soil. So of probably all the soil, but here we go. 1, 2, 3, 4, 5, 6 bags of soil are being put into these pots. So here's one for you, 1 in that pot, 1 in this pot, 3 bags, 4 bags, 5 bags. But you have 6. So you need to do what with that bag? So far, each pot is getting a whole bag. That would be like the whole number 1. Each pot is getting 1 whole. 6 divided by 5 is 1 whole bag. And then we have to do something to this last bag of soil. How are we going to get it into 5 pots? We need to divide that last bag of soil into 1, 2, 3, 4, 5 pieces so that they each get an equal amount of this last bag. I'm going to enlarge my bag just so you can see it a little more easily. If that's the last bag, I would divide it into 5 pieces. Let's see, I'm thinking about where to put my lines. Once here, 2, and it's not coming out perfectly even, but it was meant to be. This is 1, 2, 3, 4, 5 pieces. That means 1/5 for this pot, 1/5 for this pot, 1/5 for this pot, 1/5 for this pot, and finally 1/5 for this pot. They each got an extra piece. And since there's 5 pieces, they each got 1 piece out of the 5 pieces that it took to make the whole last bag. Ooh, I connected that in the wrong place. I see that. That goes here. This last piece goes to the last pot. Caught myself. So 1/5 of each of the last bag went to each pot. 1, 2, 3, 4, 5 pots. So they got 1/5 of that last bag. So each flower pot uses 6/5 of all the soil, or 1 1/5 of all the bags of soil. It's not a bag, it's the entire thing of soil. The bags of soil. That's also the same thing as 6 divided by 5. I had written that, but that's something you'll be doing in a later lesson. So 6 divided by 5 equals we just said what it equaled. 1 1/5. So the answer is between what whole numbers? It is between the whole number 1, because we already have a 1 in the answer. And what would come next if you're going that way on your number line? You have 1 whole. 1 1/5 would maybe be here. And what would be the next whole number on the number line? it would be a 2. You're between like 1 and 2 inches. You're at 1 1/5, for example. So it would be between 1 and 2 lines. All right, let's try number 4. Number 4. 40 yards of fabric, sorry, that's shaking. 40 yards of fabric are used to make 9 school banners. How many yards of fabric does each banner use? How many yards of fabric does each banner use? Between what 2 whole numbers does the answer lie? So if you had 40 yards of fabric to make 9 banners, how many yards of fabric would each banner use? Well, let's see what that would look like. Let's make sure that's lined up under there. Okay. So you have, checking that, 40 yards being made into yards of fabric. That'd be like long pieces of fabric, 40 yards of fabric, and it's being broken into 9 banners. And they would like you to use visuals today, so we're going to draw 9 banners, meaning a banner like for a school might be, could be long like this maybe, and maybe you'd hang it in your hallway. I have to draw 9 of them. It's going to take me a second here. 1, 2, 3, this could take up a whole board. 4, might have to draw some next to it. 5, I'm trying to make them the same length, pretend that they're the same length. 6, 7, 8, please pretend they're equal. We need one more. We'll do it above. 9. Okay. Those are the 9 banners, and we're dividing 40 yards of fabric into these 1, 2, 3, 4, 5, 6, 7, 8, 9 equal banners. How many yards of fabric will be in each? That is the question. Okay, let's find out. So, the fraction would look like this, 40 divided by 9, because that's what fractions mean. If you wrote it sideways, it would be 40 divided by 9 banners equals how many yards per banner? This is yards, our YDS, and we'll say B for banners, or banners. I'll just put that. And we're trying to find out how many yards per banner, yards of fabric. Okay, let's see what we could do. What is our strategy going to be? 40 yards. Well, this could be interesting. 40 divided by 9. I would think 9 times 4 makes 36. So there are going to be at least 4. 9 times 4 makes 36, which is close to 40. There are going to be at least 4. I'm trying to figure out how to do this. 1 second. Here's 2 more to work with. I drew them already in the book because the drawing takes so long. Here we go. Let's see how this looks. Demont used 4 gallons of gasoline. This is the gas. 1, 2, 3, 4. Gasoline. In 3 days. Day 1, day 2, day 3. Each day he used the same amount of gasoline. How many gallons of gasoline did he use each day? We're going to start by, this is nice and easy to see. So day 1 can have a gallon. Day 2 can have a gallon. Day 3 can have a gallon. But when it comes down to this last one, you need to divide it among the three days and share it equally among those 3 days. So let's break it into 3 pieces. And when we do that, we try and make them equal. When I draw, I'm trying to make it equal. So now that it's in 3 pieces, I can give, this would be 1/3, 1/3, 1/3, 1/3, 2/3, 3/3 to make the whole gallon. This top third can go here, they get an extra 1/3. This third can go here. This third can go here. So you would say that each day received 1 whole gallon, I think I'll write that over here, and an extra third of that last gallon, and 1/3. You could say our problem is written as 4 gallons divided by 1, 2, 3 days, which is equal to 1 whole gallon per day and an extra third. Gallons. Gallons. 2 L's. Oops. So, I was doing my thinking over here. 4 gallons, that's the top, divided by 3 days, that's the bottom, your numerator, your denominator, equals 1 whole gallon and an extra third was used each day. 1 whole gallon and an extra third was used each day. That's how they divide them up equally. Let's try this one. Suzanne made 2 gallons of punch. This is meant to be like gallons of punch. One gallon, 2 gallons. So Suzanne made 2 gallons of punch to be divided equally among 10 people. I drew 10 little people. So 2 gallons are going to be needed. 10 people will be needed. How much of the punch did each person receive? I broke the 2 gallons into 10 pieces. I labeled them broke them up ahead of time. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Each piece is worth 1/10 of the pitcher or the gallon. So 10 people are sharing this. I could draw a bunch of lines, which you could have a, 1 equal 10th of this for you, a 10th for you. This is going to be a lot of lines. 3, 4, 5, 6, 7, 8, 9, and maybe from this side, 10. So far they each received, I'm going to write 1/10 underneath. They each received 1/10 of that gallon. I could do the same thing with the other gallon. This time I need to use a different color. So let's try red. Here we go. 1/10 for you, 1/10 for you, 1/10 for you, 1/10 for you. I'm overlapping. That's another 1/10. 1/10 for you. I'm trying to show that they're all sharing it equally. Almost done. They each get a 1/10. Luckily, these numbers divide equally and evenly. So they just received their second 1/10 part of this gallon. So how much did each person get? They each received 1/10 of this pitcher and 1/10 of this pitcher. They've received 1/10 and 1/10. Logically, they've received 2/10. 1/10 and another 10th makes 2/10 they've received per person, because they each got a little bit of each of the gallons of punch. So let's write the problem out. 2 gallons divided among 10 people, once again, it equals what we just said they received, 2/10. This one does not have a whole number in it. It's not a mixed number. It's just 2/10. How much of the punch did each person receive? 2/10 of the total. The total was 2 gallons. They received 2/10 of the total punch. Little more abstract. We can't convert it into like a mixed number because the top number is smaller than the bottom number. You could reduce it when you learn how to do that. But I don't think you've had that lesson yet. But if you did, you'll divide by 2 on top and 2 on the bottom, and in the future this will shrink down to 1/5, but that's in a later lesson. They received 2/10 gallons of punch. Lots of drawing to show this. It's easier to just work it out mathematically, but I was trying to give you the visual. I hope that helps you. Have a good day, and good luck trying to draw these things for yourself. See you in the next lesson.